When a pilot's heart rate spikes in a dogfight, their display shouldn't wait for a manual keyframe. The interface needs to react instantly, pulling the live data and pushing the visual into a state of panic alongside them. We can achieve this through metadata-triggered scripting. It acts like a digital mood ring for your user interface, allowing external data to drive the design logic. We are going to build an automated environment where ExtendScript reads an external XML data file and uses those numbers to alter the design, shape, and color of our HUD in real time. Mastering this workflow transforms your role. You shift from a manual animator to a VFX systems architect who builds interfaces that can think for themselves. To build this system, we first have to allow After Effects to look outside its own architecture. By default, it operates in a closed loop. Open your Preferences menu and enable Allow Scripts to Write Files and Access Network. Without this box checked, your script will fail at the very first step. This illustrates the ingestion process. On the left is a raw XML file containing a live heart rate value. We create a data conduit using ExtendScript to pull that exact temporal metadata directly into our composition on the right. Before you run the script, check your XML file's text encoding. It must be set to UTF-8. If the ingestion engine hits unrecognized character formatting, it will crash your entire data pipeline. A common mistake is trying to process all this data by overloading individual timeline layers with heavy expressions. This bogs down the software and makes the project difficult to debug. Instead, we delegate the heavy data parsing to ExtendScript, allowing it to bake the keyframes. We then reserve expressions strictly for low-order, repetitive motion. This keeps the project lightweight and prevents cognitive overload for the developer. With the data inside After Effects, we map those raw numbers to specific visual moods. We do this using state machine logic, which prevents us from having to write thousands of disorganized if-else statements. A baseline heart rate under 80 maps to a resting condition, triggering a cyan module. iFocus on a target triggers an engagement condition, activating a yellow reticle. A heart rate over 120 routes to a critical state, driving an aggressive red glitch overlay. To comp this cleanly, we use a switch statement. This piece of logic evaluates the incoming XML data and routes it to the correct visual rule without tangling up your timeline. Structuring your logic this way reduces cognitive burden. The software knows exactly what to render, and you maintain a clean system that follows Hick's law of simplicity. Next, we connect these logical states to our actual graphics. We do this by targeting the parametric UI modules inside the Essential Graphics panel. We use the setValueAtTime command. This acts as the muscle of our script, physically injecting the parsed biometric data directly into our master properties. Mapping raw data frame by frame creates a visual problem. Sudden jumps in heart rate result in rigid, robotic animations that snap violently from one value to the next. To solve this, we apply ExtendScript-based temporal interpolation using the keyFrameEase object, smoothing the rigid line into a fluid curve. For a multi-dimensional property like position, you must enclose your X, Y, and Z values in bracketed arrays, or the script will crash. These automated easing rules ensure the HUD remains legible during high-stress data spikes. When movement follows a natural, predictable curve, the eye can track critical information without being distracted by jarring mechanical jumps. Now we test the system. Opening the external XML file and typing in a single new heart rate value instantly triggers a cascade of specific color, size, and speed changes across every module in the composition. You have successfully built a high-fidelity parametric template. As an advanced next step, you can replace the static XML file entirely. By utilizing the socket object within ExtendScript, you can ingest live biometric streams from a wearable device directly into After Effects while it renders. By engineering intelligent, context-aware systems, you move from simply placing frames to building an environment where the narrative data dictates the visual performance.